This is Sheldon, Ivan, and I, and we're working on using neural networks for unsupervised cipher cracking.
Imagine you have two different books placed before you, the first in language X and the second in language Y. You know an expert of each language, but neither expert knows anything of the other's language. Your goal is to learn to translate from language X to Y and vice versa without knowing how to speak either language, and without any sample translations being given to you. It might sound impossible, but there's an extremely elegant solution. We can choose any two languages that do indeed have some translation between them. The first objective we want to achieve is reconstruction. When we translate from English to French and then back again, we want to arrive back at the same sentence we started with. Here we erroneously mapped dog to chat and correctly mapped chat back to cat, which resulted in an inconsistency between the input and its reconstruction. Let's suppose that we instead map back from chat to dog, so that there's no reconstruction error. Now we have a mapping that satisfies the reconstruction, but we can clearly see a mistaken translation between dog in English and chat, which is cat, in French. This is where we can rely on our expert of French. When we show our French expert the French sentence, "a cat barks," it's very obviously an unnatural sentence, and the expert informs us of some more probable occurrences with which we can update our mappings. Our project is a first step towards the lofty goal of unsupervised translation. We treat plaintext and ciphertext as two different languages, replace our mapping functions in both our experts with neural networks, and learn to automatically crack ciphers over natural language. Our methods have already seen exceptional performance on Caesarean ciphers, and next steps are to scale up our experiments to more complicated ciphers, such as Vigenère and Enigma. Our methods have the potential to be put to use in recovering lost languages, decoding enciphered texts, aligning between black box schemas, and more. We'll be open sourcing all our code and integrating with Google Brain's tensor-to-tensor framework to facilitate rapid future development by the community. Thank you so much for your consideration and support of open research.